7.3 is on inscribed angles. So we've already learned about central angles. Do you guys remember what a central angle was? It's the angle that is in the center of the circle. So the vertex is the center. Okay, this is something different. Do you guys see how this looks different than the central angle? So a central angle was one that started on the center and went out here. Oops, missed it. Okay, this other one is going to be called an inscribed angle. So it touches, it's inside of that circle. It touches along the edge of the circle. Okay, so this one is a central angle. And this one is an inscribed angle. Okay, these are totally different. Okay, looking at these pictures, which one do you think is greater? Do you think the central angle opens up more than the inscribed angle, or is the inscribed angle a bigger angle? Are they both the same? I don't know. Look at it. Which one looks like it opens up wider? The central angle looks like it's more like, it looks like it's more than 90 degrees probably, right? But the inscribed angle looks like an acute angle. Do we see that? So they are not the same, but they're related to one another. It ends up being exactly double the other one. So the central angle is double the inscribed angle. So an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. An intercepted arc, so this part that I'm going to draw in red, is called the intercepted arc. So see how that's an arc, not an angle? Is an arc that lies on the interior of the inscribed angle. The way I always describe it is think about Pac-Man. Do you guys all know what Pac-Man looks like? So Pac-Man is eating the intercepted arc. Okay, so it says on a separate piece of paper, construct a circle. So we're not going to do this, but I just told you what it was. So it says if an angle is inscribed in a circle, so we have this angle that's kind of on the outside of the circle. It touches along the exterior, or not exterior, along the edge of a circle. Then its measure is exactly half of its measure of its intercepted arc. Because do you guys see the intercepted arc? If that was like 100 degrees, then this is 100 degrees. So then this other angle would end up being 50 degrees. Okay? So it's going to be half the measure of the intercepted arc. So it says find the measure of the intercepted arcs. So I have 70 on the outside. So if you think about it, the intercepted arc is the same as the central angle. Well, how's the central angle related to the intercepted arc? It's double, right? So what's the intercepted arc then? 140, perfect. How about the next one? We have 90 here. So what's the measure of arc ADC? 180. Doesn't that make sense that it'd be 180? Yeah. This is actually a theorem that we're going to talk about in just a little bit. So if we have a diameter, every intercepted angle, or every inscribed angle that we draw in there will have a 90-degree angle at the top of it. Okay, measure of ADC. So ADC going around here. What do we think? I don't think it's 262. What is this? What's 98 doubled? So it's almost 100 doubled. 196? Yeah. All right, the next one. So find the measure of the inscribed angle. So if I have 120, what's this inside angle? Measure of ABC? 60. Perfect. The next one? EFG, well, this was 180, right? Yeah. So what's EFG? 90. Or the measure of PQR. PQR, how are they related? Yeah, it's half of it, so it's 24. So do you guys know how to go back and forth between each one? How to tell which one's bigger, which one's smaller? The big thing is people forget. They're like, ooh, do I double or do I halve? Well, you just have to think about which angle is bigger than the other. If you need to draw on the central angle, you can. Okay, so it says the star divides the following circle into congruent arcs. Find the measure of the angles that are the points of the star. So if you notice that we have 1, 2, 3, 4, 5, 6, 7 sections. Do you guys see how we have 7 sections that are all equal? So each of those red little arcs, how much would each of those red arcs be? So I already see Joe doing it for us. What are you putting into your calculator there, Joe? Yeah, these are all 360 divided by 7, right? Which is around 51.429. So it says, well, what are the measures of the angles that are the points of the star? Well, let's look. The point of the star, so if I talk about angle 4, and I kind of extend it, How many of those arcs is the Pac-Man mouth eating? How many of them? 4. Nope. How many of those little red pieces? 1, 2, 3 of them, right? So from here over is 360 over 7 multiplied by 3. So if I take my answer and I multiply by 3, I have like 154.289, somewhere around there. So then how do I get the measure of angle 4? I take half of it. Yep, so divide by 2. So I get 77.143. And if you kept everything in your calculator, you can do math 1. You can get the fraction form. It's 540 over 7. So if you kind of keep doing answer, answer, answer on your calculator, you can always change it back to a fraction if you want. All right, does this make sense? Do you guys get it? Okay, we can skip this one. Let's go ahead. Huh? I like fractions, but I mean, in geometry, I'm not too picky about it. Once you're in like AP Calc, I make you give very precise answers. All right, so it's given that measure of angle B is equal to 55. So if I have this angle is 55, what is the arc AD? What's that going to be? What do we think? Nope. Okay, look at the intercepted arc, Pac-Man. What's Pac-Man eating? 110. And then what about angle C, though? What's measure of angle C? It's also 55, right? Because it intercepted exactly the same. Oh, were you guys on the other one? We're like, what are you talking about? All right, so that's a theorem. So if two inscribed angles intercept the same arc, then those two angles have to be congruent. So if they have the same part that Pac-Man's eating, then this and this have to be the same. Okay. And an inscribed polygon is a polygon whose vertices all lie on the circle. So maybe I have like an inscribed quadrilateral. That would be like an inscribed polygon. So in these pictures, when we have an inscribed quadrilateral, these two angles end up being supplementary. Okay, and there's a theorem that proves that. So those two will be supplementary. And these two will be supplementary as well. Okay, so that might help you on your homework, so kind of look at that. All right, I think I'll stop there for now. We can do those last examples. Remind me on Monday to do those last ones. But